Do you ever have that feeling that sometimes your life is a bit like the Beverly Craven classic, 4 o'clock in the morning, and it's starting to get light? It's 6:38 on a Monday morning. I'm between stages on the SSH story today, which I'm going to explain a little bit more. But yeah, Beverly Craven, amazing. Yeah, it's 6:38 and it's starting to get light.
The Little Root Lab is a homegrown, self-learning journey into IT and cybersecurity, narrated by Simon Arnold. It is being built from the ground up, documenting progression through systems, networking, and SOC concepts as it develops, including the mistakes, the learning process, and the real-world growth that comes with it. It is hoped that viewers find value in the series and are able to take something useful from the journey as it unfolds. Enjoy.
Hello and welcome to the Little Root Lab. Good morning, it's a bit early and my lab is still asleep, apart from my normal driver, which is Mac OS, which I'm recording on today. So welcome back. And today's topic is understanding network services through a mini SOC lab. So welcome back and thank you very much for always tuning in. And it's probably going to be one of two podcasts today. I'm in between phases at the moment. And yeah, I just guess I want to just get rid of that buffer that's in my way today. So welcome back. You know, when you start building a small SOC lab at home, it's easy to focus on the tools. You know, things like SSH, Linux, or a SIEM platform like Wazuh. But, you know, what actually makes the setup useful isn't the tools themselves. It's understanding the different types of network traffic these tools generate and how security teams can interpret that traffic in layers. Now, last night, about 10 o'clock, I was looking, because I take so many screenshots, and I was looking at DNS and HTTP and HTTPS, and then of course, you know, therein lies the SSH22, you know. And it's really just, I'm always pattern recognition. I'm always putting things together in their kind of boxes. You know, how does that reflect with that? Does that work with that? Oh my goodness, I broke this. Why was that? You know. So in this episode I'm going to break down 4 core concepts that appear constantly in real environments. Like I said, you know, you've got DNS, HTTP, HTTPS and SSH, and how they all behave differently inside a simple lab setup. So let's go into it slowly. So the big picture, you know, what a SOC actually sees. So from doing so much work on my own SOC operations center, you know, analysts aren't just looking at individual systems. They're looking at flows of activity across a network. And every action, whether someone opens a website, logs into a server, or resolves a host name, generates logs somewhere, right? So instead of thinking I have Windows and Linux connected, it's more accurate to think I have multiple network services generating different types of observable behavior. And that's where DNS web traffic and SSH come in. Now you know, it's like a slow burn with me, and this is why I'm doing this podcasting. Then we go into section 2 really, which is the DNS, the quiet first step, and that's port 53 of course. I mean, let's start with DNS because it happens before almost everything else. So DNS runs on port 53 and its job is simple. It translates human readable names into IP addresses. I think we all know that anyway, don't we? So when you type something like server.local, the DNS resolves that into something like 192.168.x.x, okay? But in a SOC context, DNS logs are actually, and I didn't realise this till really now, that they're actually really valuable because they show intent. And before any connection happens, SSH, HTTP, anything, DNS often reveals what a system is trying to reach. So even in a lab, DNS helps you understand the first step of communications, name resolution before connection. So when we look at HTTP and HTTPS, of course, which are ports 80 and 443 respectively, then we're basically looking at web traffic, of HTTP and HTTPS. I love the little S in the end being security. HTTP runs on port 80, as we know. HTTPS runs on port 443. And this is the layer that most people are familiar with, of course, because it powers websites, dashboards, APIs, and almost everything we act in within a browser. But from a security perspective, HTTP and HTTPS traffic is important because it often represents, of course, the user activity, data transfers, and application communication. But the key difference really between HTTP and HTTPS is encryption, of course, with S being the security. HTTP is plain text, meaning traffic can be inspected directly. HTTPS is encrypted using TLS, remember, meaning the content is protected, but metadata like destination, timing, and volume are still visible. But in a SOC environment, even encrypted traffic still produces useful signals. Now let's get on to my main crux of the matter today, and that's SSH, the Secure Remote Access Port 22. And before we start really going into that a little bit more, I've got Wazuh all set up. I changed some parameters, so that's running better now. To look at 120-second log check, I think. But when we look at SSH, the secure shell, on port 22, this is what really connects directly in my lab setup between Windows and the Linux. So I'm just going like a layer below the knowledge, if that makes sense. So SSH is used for remote administration, usually of Linux systems, and as you all know, I'm using Ubuntu because I find it more user-friendly with Plasma rather than using GNOME on Ubuntu. But it allows me to run commands securely over the network. But from a security monitoring point of view, SSH is one of the most important services to observe because every login attempt generates authentication logs. And that includes successful logins, failed login attempts, repeated authentication attempts from the same source, right? And in real-world environments, SSH is frequently targeted for brute force attacks or credential guessing. And this is what I'm starting to do. So even in a safe lab environment, SSH is a perfect way to generate realistic security telemetry. And before we get into it a little bit more, it was kind of like I've just done a sudo apt update. I've just done a sudo apt upgrade. In between, I've been putting in some, not minus TULMP, I think it was more like TLMP or something like that. Got to get my head around this one. And of course, this podcast is about learning and continuous movement forwards, and just learning stuff as we go. And it was really nice to see Jason pop up yesterday with the JSON, and I've always wanted to uncover that part as well. So it's thoroughly interesting. But let's get back to how these layers work together. So slowly I'm working out how everything connects. These services don't exist in isolation, they actually stack together. And I guess I'm coming around to this kind of idea because for a good 3 months everything was air gapped, and And now I've got the Ethernet cables in for the lovely secure connection. And, you know, a typical flow might now look like this, really, which is first the system performs a DNS lookup to resolve a name. Then it might initiate HTTP or HTTP traffic into a service. Or, in a more administrative scenario like my lab, it indicates an SSH connection to a Linux machine. And any of you out there that are listening that are actually building a lab from scratch and using Windows 10, always plug into the, into the bash administrator, because that's going to save you so much time than faffing about in between. So the DNS determines where you go. HTTP, HTTPS handles web-based communication. SSH handles secure administrative access. And this is all really good learning right now, because to start with, over Christmas, a few months ago, I was just really learning SSH 20 and all the numbers, but really didn't have any much grounding from it. So each one generates different logs, and each one gives a different type of visibility into what system is doing, of course. And this is where Wazuh fits in. You know, seeing that little blue fox kind of, it's like, okay, cool. First of all, I thought it would be something that I would actually see, like an icon on the desktop, but it wasn't. And Wazuh collects logs from systems, in this case, particularly from the Linux machine, handling SSH connections. It then structures these logs into security events. So instead of raw text entries, you start seeing patterns like repeated failed login attempts, which if you've been following my podcast over the last couple of days, we've been starting with that. Successful authentication events, unusual access behavior, and in a real SOC, this is how raw network activity becomes actionable security intelligence. DNS shows intent, HTTP, HTTPS shows application behavior, and SSH shows administrative access. And Wazuh ties it all together into something you can monitor and alert on. I mean, for all of you with advanced cybersecurity knowledge and everything, I could imagine that DNS is really not the favoured route to actually bring a system down. It's surely just going through the command line, right? Through the PowerShell. But that's another topic. Just please leave your comments down below, because I'm always trying to learn, and we can learn from ourselves and doing it all and helping people come up as well with the new information that I'm learning. It might help them, but also kind of top down, it would be nice just to get some of you that are more advanced just to chip in a little bit, because it helps everyone then. So why does this all matter, really? I mean, what makes this setup useful isn't the complexity, it's the clarity, right? A simple lab like this lets you observe the same traffic types that exist in enterprise environments, just in a controlled way, And I had it air-gapped, and when I put it all with the Ethernet, and I've got to look at my TP box today, TP link box, and I think I'm just going to reroute the Ethernet cable from, the Ethernet cable running from Windows 10 is actually fine, because it's going into my digital box from Vodafone. Again, I'm getting really, really annoyed with just the infrastructure here in Germany, because it's not very good, actually. But never mind, we've got to do with what we do, right? So, you start to see that security isn't about one tool or one protocol. It's about understanding how different types of communication generate different types of data. So once you see that pattern, and as I said at the start of the episode, I am Mr. Pattern Recognizer, So DNS resolving names, web traffic, moving data, SSH handling access, everything in networking starts to feel more structured and predictable. So the goal of this lab isn't just to connect systems, it's to understand what normal network behavior looks like across multiple services, and how security tools like SIEMs turn that behavior into visibility. And once you understand DNS, HTTP, HTTPS and SSH as part of a single system, rather than isolated topics, you're already thinking closer to how a SOC analyst thinks in a real environment. So I'm going to drink my tea, get my lab all fired up, change around some Ethernet cables, probably link up the the Kubuntu Ethernet from my Mac, into my digital box really, and just go for the SSH, because I thought that actually SSH was, I'd already done it with sudo apt update and sudo apt upgrade, but of course I needed to put in SSH somewhere as well for it to actually perform that function. So thanks for listening. I'm probably going to record a episode later, so there's going to be most likely 2 podcasts going out today, but thanks for listening, appreciate it, and I'll catch you later.